Last week we talked about, the last 2 weeks really, we've talked about exponential type functions. And the reason why we spent so much time on exponential functions is so it'll help you with logarithmic functions. So whenever we deal with a log and an exponential are really just like, they're inverses of each other. Okay? They are sister functions, or they're kind of like siblings. They're just opposites of each other. Because you can write any exponential function as a logarithmic function, and you can do the same thing with a logarithm and turn it into an exponential. So whenever we have, it says determine the value of x for the expression. So 2 to what power gives you 4? Second power. Okay, so if we have 2 to the second, we would get, so 2 to the second gives me 4, so x would be equal to 4. Or excuse me, x would be equal to 2. Same way, 8 to what power gives you 0? Anything to what power gives you, or excuse me, gives you 1? There you go. So 8 to the 0 power gives you 1, so x would be equal to 0. Same thing on 3. If we have 2/3 to the x power, what did we do to get the 8 on top and the 27 on bottom with the 2 and the 3? What power did we take everything to? 2 to the third and 3 to the third would give me 8 over 27. So x is going to be equal to 3. Whenever we have 4, if we have 4 to the x power, what did we do to the 4 to make it into 1/4? We just flipped it, right, and made it negative, so x would be a -1. When we have 4 to the x power and we take it down and we make it into a 2, what power did we take it to? What? Say it, Lauren. I think you were right. A half. Because it's the same thing as a square root, right? Okay. So you take it to the half power. Whereas here with, like on 6 is going to be like a mixture between 4 and 5. If you have 4 to the x power and you make it into a 1/2, x is going to be equal to the -1/2 power. Because what is, if we make it 4 to the 1/2 power, we turn it into 2. If we do a negative from there, then we get it into a 1/2. So we had a -1/2. Okay? It's just a mixture of 4 and 5 kind of put together. Whenever we have a logarithm with a base of b, like I said earlier, logarithms and exponential functions are just sisters of each other. Sisters, brothers, whatever you want to call it. Okay? They are inverses, and we can rewrite any log as an exponent. We can write any exponent as a log. Whenever we read this, we always say log base b of y is equal to x. If we call it log base b, okay, a log is always going to have a base the same way an exponent is always going to have a base. Whenever you have an exponent, the base is your bigger number and your exponent is your smaller number. Whereas here, the base of your log is always going to be the tiny number, and then your power is whatever's on the other side of the equal sign. So all that's going to happen is whenever I do this, okay, and the easiest way that I would tell you is whenever you start with a logarithm, whatever your base is, keep it on the same side. Never move it around. So like if I have a log base 2, the 2 is going to stay here, and it's going to be my base of my exponent. Everything else is going to change sides. The 4 becomes my exponent. The 16 becomes my answer. What is 2 to the 4th? What's 2 times itself 4 times? 16. Same way goes for 2, or B, whatever letter you want to call it. The 4 doesn't change. I'm just going to drop it straight down, and it's going to be 4. The 0 comes over, it's my exponent. The 1 goes to the other side of the equal sign. What's anything to the 0 power? 1. Same way on C. What's C going to look like? How am I going to rewrite log base 12 of 12 equal to 1 as an exponential function, or as an exponent? 12 to the first power equals 12. All we did was just drop that 12. We brought the 1 over, and we sent the of number over to the other side. The base of your log will never change sides. That's the biggest thing that I would tell you. Okay? I would never change the base of, if the base is on the left side, keep it on the left side. If the base starts of your log on the right side, keep it on the right side. And just change your of and whatever the opposite side of your log is. So same way on D, if I have 1/4, 1/4 is just my base. I would tell you if you have anything that's a fraction, put it in a parenthesis. The negative 1 is going to come over to the other side. The 4 is going to slide over to the other side, and we're done. I can write, the same way that I can write a log as an exponential is just the reverse order of taking an exponential and rewriting it as a log or a logarithm. Again, the base of whatever my exponent, it's not going to change sides. So this 5, that 10, the 6, or the 8, they're all going to stay in the same spot, and I'm going to have log of a little bitty 5. Same way like I did before, the 25 is going to come over to the other side, the 2 is going to go to the other, and I'm done. The base of whatever I have, whether it be the log or the exponent, it's never going to change sides. Everything else will change sides. So similar to B here, I'm going to have log base 10 of 0.1 is equal to -1. I move everything. If it's a negative on one side, I move the negative and everything over to that one side. If it's positive or if it's a fraction, move everything. So same way on C, if I have log base 8 of 4 is equal to 2/3. 2/3 goes over, 4 comes, they just trade spots. They trade sides is all they do. So the same thing goes whenever I evaluate. If I have log base 4 of 64, if you're not sure how to do this, turn it into an exponent. Basically, it's equal to x. So it's 4 to the x power, so 4 to what power gives me 64? How many times do I need to multiply 4 by itself to give me 64? 4 times 4 is 16. 16 times 4 is 64. So how many times did I multiply 4 by itself? 3 times. So x would just be equal to 3, or log base 4 of 64 is 3. Now, one thing that I would pay attention to is if you have anything that's a decimal, change it into a fraction. So instead of doing log base 5 of 0.2, that's just 1/5. Okay, it's going to be easier for you to see a fraction than it is a decimal. Because 0.2, you can kind of, I think, for the most part, if I have 5 to what power is going to give me a 1/5. What did I do to my 5 to turn it into a 1/5? I just flipped it, right? So what is what is this equal to? -1. So x is equal to -1, or log base 5 of 0.2. If you have a decimal, though, make sure you change it into a fraction. That'll make things a lot easier. Same way, if I have log base 1/5 of 125. So then I'm going to have 1/5 to the x power is equal to 125. So first off, what did I have to do to make it? It went from a fraction to a very large number, or a larger number. So what did I do with the 5 first off? If I took the fraction, I made it into a whole number. It's negative, I flipped it. Okay, so I know that x is going to be negative. So if I kind of work somewhat backwards, or kind of in steps, if I make it a -1, then that's going to make it a +5. So I know that it's going to be negative. So what do I need to do to the 5 to make it into 125? Five to the third is 125, right? So what power is this actually to? -3. So if you have to flip anything, either making it bigger or smaller, okay, it's going to most likely be negative. If it goes from a number that's between 0 and 1 to a number bigger than 1, or vice versa, number that's bigger than 1 to a number between 0 and 1, it's going to have a negative. Does D, though, have a negative? Did it go from, if I have a base of 36, it got smaller, but did it go between 0 and 1? No, so 36 to what power is going to give me 6? Yeah. (36 to the 1/2 power, or the square root of 36, gives me 6. Okay. If your value gets smaller, but it doesn't go above, if it's still above 1, it's most likely going to be taken to a fraction as your power. Now here's the easy part. Is whenever it says to evaluate. So it says evaluate log of 8. If you don't have a number, okay, log base 10 is also written as log of x. Like log base 10 of x is the same thing as log of x. If you don't have a number, okay, that you see with your logarithm, then that automatically means that your base is 10. With any calculator, graphing, scientific, iPhone, Android calculator, whatever you use, whenever you type in log, it's always in base 10. So it says to evaluate log of, or log base 10 of 8. All you have to do, again, like I said, this is the easy part. You're going to go to your calculator, you're going to hit log 8, enter. You just evaluated it. Okay? It's when the only time that you're going to use the calculator, and if you need to close it, you can. So like even the same way with the natural log, what is it on B? Or what's the second part? Natural log. So instead of log, you're going to hit natural log. And then what's my number? I don't remember. 0.3. I'm going to type in 0.3. I can close the parenthesis, and I'm going to hit enter. And I'm going to have negative 1.20. I'd probably just go negative 1.20. It really is that easy. Okay? The only time you're going to need your calculator or use your calculator is when you can't do it by hand. When can you not do it by hand? 10 to whatever power is equal to 8. Okay? We don't know the value. Okay? All this is saying right here is that 10 to the x power is equal to 8. I have no clue. Okay? Because it's not a value like normally 2 to the third is 8. 2 to the fourth is 16. It's not two numbers that are relatable to each other. Okay? The ones that we can do by hand are the ones that whenever we had our table and we had 1 and 2, 3, 4, and we had like 1, we had 4, we had 8, we had 16, we had 32, we had 9, we had 27, we had 81, we had 243, 16, 64, so on and so forth. All of these we can do by hand because 2 to a certain power gives me 16. 81, 3 to the third, 3 to the fourth is 81. 3 to the fifth is 243. Those are nice and neat values. If we needed to know what log base 3 of 243 was, we can go to our table and say, well, there's 243, there's 3, it's a to the fifth, so it's the fifth power. It's ones like 10x or 10 to the x power is equal to 8. We know what 10 to the first is. We know what 10 to the second is. We know what 10 to the third is. Okay, 100, 1,000, 10,000, so on and so forth, and continue to go on. But we don't know what 10 to the x power whenever it's going to equal 8. Okay. A lot of it's going to come all back from that table. Okay, and kind of going in and out and kind of how everything fits. But there are some cases like we have here where you're going to have to use your calculator or make sure you have one.